Hi everybody. Well, I sure hope Chapter 9 went well for you, the systems of equations. I know that was a tough one probably for a lot of you. This chapter is about radicals, square roots and cube roots and fourth and fifth roots. So kind of shift gears and look at something else here. So let's see, we're on 10.1 and we'll talk about just the basics of radicals today, if you don't mind. So let's talk about radicals. Okay, so I'm just going to do something that looks like this. Okay, I read that as the cube root of x. Okay, so this piece of it right here is the radical sign. This is called the radicand. So that's the thing underneath the radical sign. And this number here is called the index. Okay? So if we have no number in there, let's just put, one that you know. The index is 2. We just don't write it. Okay, so we just assume that it's the square root of 49. So what is this asking me for? I'm looking for one number multiplied by itself twice. That's going to give me 49. One number multiplied by itself twice, that's going to give me 49. Well, I know that's 7. Right? And here when we evaluate these, we always use the positive value. I also know that it's -7. And we're going to use that later when we're solving. When we solve, we use both of them. But when we just evaluate and we don't have an equation to do anything with, then we just use the positive value. This is called the principal root. Okay, so we're just going to use this one. All right. So basically, that's the basics of radicals. And the only other thing that I really want to do to show you is the formula for radical to exponential conversion. Okay, so you're going to need this. It says that if I have the radicand raised to some power, and I'm taking a root of that, it's the same thing as that same number or expression or whatever you've got raised to the n over mth power. Okay? So these are equivalent. Let's try something. Let's try one just to prove to ourselves that we can do that. All right, so let's say I wanted I've got 9 and I've got it raised to the, let's just say there's a 1 on here, and then let's just take the square root, which is, there's a 2 in there. Okay? That's the same as 9 raised to the 1/2 power, right? 1 divided by 2. So these are equivalent according to this formula here. So let's check it out. We've got the square root of 9, which is 3. Or if I raise 9 to the 1 divided by 2 power, I should get a 3. And I do. So these are equivalent statements, and we're going to need that for some of these problems here. Okay. Now this one's always telling you to do everything by hand if possible, but again, we can just use our calculators if we'd like. So we'll take the square root of, it doesn't have to be a nice neat number. So we're looking for one number that's multiplied by itself twice. That's going to give me 0.09, and it's 0.3. 0.3 times 0.3. So some of these are going to be really simple. Okay? We don't even have to hardly work on them. Okay, we can put fractions underneath there. Let me show you something by hand on this one. Okay, we have something called the quotient rule with radicals. The quotient rule says that if I have division underneath a radical sign, I can separate them, and each piece can get its own radical sign. So for this one, I've got the square root of 9/4, And that can be considered the square root of 9 over the square root of 4. And these I can do in my head. I know that 3 times 3 is 9 and 2 times 2 is 4. So I've got 3 halves on that. Okay? So some of these are going to be really simple. Alright, so this one, let's take a look at what we've got going on as far as this goes for this one. Okay? I have the square root of x to the 6th power. Let's go right here. The square root of x to the 6th power. Well, I know there's a 2 in here, so I'm going to write it in there. Okay? And I'm going to use my conversion because I can't use my calculator. I can't put x's in here and get a number back out or anything like that. So I'm going to use this conversion. I'm going to turn it over to an exponential and see if it is more workable than as a radical. So this is telling me to take the power inside here, n divided by m. So this is 6 divided by 2. Okay, so it's 6 divided by 2. And 6 divided by 2 is 3. So this is the same thing as x cubed. Okay, so that's what we would put in here. So remember, you're going to put your base down first, and then you're going to use your power key with the 3. Oops. Okay. All right. Same thing here. Okay. I can do it by hand, but I'm going to use the calculator. Now remember, in my math key, number 4 is my cube root. Okay? So what this is asking me for is give me a number multiplied by itself 3 times is going to give me 8. Well, I know that's 2. It's 2 times 2 times 2 is 8, but we're going to use the calculator to verify that. So we'll pick option number 4, and we'll put the radicand in there. So we want the cube root of 8, and that's a 2. Okay? How can I take the root of a negative? Well, I can if this is an odd index. Okay? If it's an even index, I can't. Then it's not a real number. We've already looked at that. So again, I'm going to hit my math key. I want option number 4 for the cube root. I'm looking for the cube root of negative 27. I'm guessing it's negative 3 because negative 3 times negative 3 is a positive 9, and positive 9 times negative 3 is negative 27. Yep. Okay, so these can be negative if the index is odd. Alright, let's put that one in completely from scratch here. Alright, so I have a negative 343, right, divided by 64. And then I can do math enter because it's going to want that fraction. So I've got negative 7/4 on that. Okay, so that's what this is asking me for, is a simplified fraction. So some of these, most of these I can do with my calculator here. You know, these kind I can't because these have x's in them. Okay? So what is this asking me for? Well, it's asking me for the opposite sign of the cube root of x to the 21st power. So just ignore this negative for a little bit. Okay? Let's just do the cube root of x to the 21st power. I'll switch that over to an exponential. Okay, 21 divided by 3, right? I can simplify this to a 7. And now it's telling me to take the opposite sign. Well, this all came out to be positive, so this would be a negative. So it's just negative x to the 7th. Okay? I'm not going to check some of these. It's going to take too long. I'm trying to get this lecture in. Alright, so now we want the fourth root. The fourth root of 1296. So I want a number multiplied by itself 4 times will give me 1296. Well, I'm not going to even bother trying to figure that one out. So I'll let the calculator do that. So on these, we have to hit the index first. Then we go to the math key and we want option number 5. That's just any root. Okay, so this is your square root right here in blue. This is your cube root right here, and then this is your any root. So then I want a number 5. And it's going to replace that 4. It's going to put it in that X spot. And then we want 1296. So 6. So what is that telling me? 6 times 6 times 6 times 6 should give me 1296. Okay? Okay. Same thing here. We want the 5th root. Okay? We want option number 5. And we want a negative 32. Negative 2. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is negative 32. So I'm going to let you go on these. Oh, no, I have to do that one. All right, let's try this one. Sorry, I didn't even see that one. So we're going to do this. Okay. I want option number 5. Negative 256. Quit. Okay, let's just quit. No, because this is a negative and because that's an even index, there is no number multiplied by itself 4 times. It's going to give me a negative. Okay, so this one's not real. This is not a real number. We're going to get to these. These are imaginary or complex numbers. They are very real as far as they exist. I hate that. I hate those taglines of real and imaginary because then it makes it seem like one exists and one doesn't exist, but they're just names. It's kind of like proper and improper fractions. Well, it doesn't mean one's right and one's wrong. It's just the name of the fraction, but we associate the regular meaning to those things. So don't think that these are they don't exist. They certainly do. All right, so we can't do that one yet. All right, so this is just we're just getting more practice. So here you're rounding. These are not going to come out nice and neat. So we're going to do option number. I'll just do one of these. Option number 4. We've got the cube root of 34. Okay, rounded to the nearest hundredth. That's 2 decimals. Okay, so that'd be 3.24. And I don't know how many of these we have in there. Just 1. Okay. If possible, evaluate the function at the given values of the variable. Okay. Well, what we're doing is we are evaluating the function at a value, which we've done, right? So if we have our function, we have 3 minus 3x, and we want to evaluate x is negative 4, so we want to evaluate f of negative 4. Then what I would do is I'd put and replace wherever I see an x, I put a negative 4. Okay? 3 minus 3 times negative 4. Okay? You can consider this to be like a parenthesis. You want to do everything underneath that radical before you do anything. Okay, so I've got 3, and I've got a negative 3 times a negative 4, which is a positive 12. And then I want to add those. And then I want to evaluate. I want to look at the square root of 15. Now, what I want you to do on a calculator is, if you need to, is put it in your calculator and see, does it come out to be a nice, neat whole number, or does it come out to be a messy decimal? If it comes out to be a messy decimal, and they want an exact answer, then we have to put our answer in this way. Why is this one exact and this one's not? Well, because 3.872983346 is a rounded answer. It's only going to go out so many decimals. My guess is that it goes out many more decimals than this, so we're rounding this. So this is not an exact answer, it's an approximate answer. So if it's asking for an exact answer, then it's going to want the radical in there. So you're going to want to choose your radical. Okay, this one's for the nth root. This is not a square root. This one's a square root. And then we'll put a 15 in there. So you have to be careful too. You have to make sure that the index here matches whichever button you've got. Okay? All right, and then you'll do it again for 9. Let's do it again for 9, since we were right here. F of 9. Okay, so again, I'm replacing my x with a 9. 3 minus 3 times 9. And negative 3 times 9 is a negative 27. Right? Now I subtract. 3 minus 27 is a negative 24. I've got an even index. I can't take the square root of a negative number, so this is not real. Okay, so that will be in the complex world. You just have to be careful about those. All right. Same thing here. We've got the cube root, and we're going to evaluate. All right. Let's try one of these. All right. We have f of x is equal to the cube root of x squared minus 9. And we want to evaluate at negative 15. So we replace the x with a negative 15. We're going to retain our index of 3. So we've got a negative 15 squared. And we're going to subtract 9. So I'm going to do everything underneath that radical sign first. I'm going to just do everything, you know, one thing at a time. Don't do too much. Don't try to get everything in there. You know, don't do 15 things on one line. Just do one thing at a time. 225 minus 9. And then we're going to take the cube root. Now I'm going to subtract 9, and then I'm going to see if I can't. So that's 216. Okay, now I'm going to see whether or not that's a nice neat number or not. So I want to go into my math key and get my cube root. I want to see whether or not 216 is a perfect cube. It is. It's 6. So that's what I'm going to put in here. 6 is exact. Okay, 6 is a nice exact number. So I can put that in there. And then I'm going to do it again for 6. Okay? I can do all of these for you. Yes, 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 yes. All right, so again, same thing. You're going to evaluate. All right, let's do one of these. So here I have my function, f of x is equal to the square root of x plus 44 plus the square root of x. And I want to evaluate f of 100. Okay, I've got two x's here. I've got to put it in both spots. So I've got 100 plus 44 plus 100. Okay? So I'm going to add these two for the square root of 144 plus the square root of 100. Square root of 144 is perfect. I'm pretty sure that that's 12. So we're going to just check that. So we're going to do 144. Yep, 12 times 12. Square root of 100 is 10. Okay. Verify that on the calculator. Okay. So really what I have here is 12 plus 10. This one's 12, this one's 10, and I'm supposed to add them for 22. Okay? That's an exact answer. Not one I don't have to mess with. All right, so now we're going to talk about domain and range again, your favorites. All right. So what I'm looking for here is what kind of numbers can I put in there and not get that error message on my calculator. Well, the first thing that I want to realize is that I have an even index. It's the 2. Okay, so that means I can't have anything negative underneath that radical sign. Is that true? Yes, that's true. I can take the square root of 0, and I can take the square root of a positive number, but I just can't take the square root of anything negative. So what that's telling me is that the piece underneath this radical sign has to be bigger or equal to 0, right? Whatever I have underneath here has to be bigger or equal to 0 for me not to get that error message on my calculator. Well, I know how to solve inequalities. So I'm just going to add my 12 across. So x has to be bigger or equal to 12, right? If I put 12 in here, I get 12 minus 12 is 0, square root of 0 is 0. If I put 16 in here, 16 minus 12 is 4, square root of 4 is 2. So I'm getting real numbers in here. But if I put something less than 12, so let's put a 10 in here. So 10 minus 12 is -2. I can't take the square root of -2. All right, and we want interval notation. Remember that stuff? So we want to include 12 because 12 is a valid number in here. So we want to use the bracket, and we want to go all the way up to infinity, right? And infinity never uses the bracket. So that's what we want there. We want the interval, so any number including 12 up will work. Anything below this will not. Same thing here. Okay. Don't forget to flip your, maybe we should do this one. Don't forget to flip your sign when you multiply through. Again, we have a 2, so I can't have anything negative underneath there. Or if it was a 4 or a 6 or an 8. Okay, any kind of an even index. So I know 7 minus 4x has to be bigger or equal to 0. Okay, this is what we're looking for, is the domain. I'm solving for x. So I subtract my 7 across. So I have -4x is bigger or equal to -7. Now I divide through by -4. Right? Since I divided through by a negative, I'm going to flip my sign. Remember, I forgot to do that last time. So I've got 7/4. So less than or equal to 7/4. Okay? We want that interval notation again. And remember, we want to go, since we're going down to negative infinity, we want that one first. Okay? So we want the parenthesis first. Remember, we always want the smaller number to the left. Right? I should say correct. And then we want 7/4 here. And 7/4 is included in the interval set. Infinity is never included. Okay? This looks really weird. This one's really small and this one's really large, but that's just the way that my math lab does things here. So, all right, what else do we? Oh, we're almost done. Okay, so let's start graphing. Okay, let's use the calculator to show us how it's looking. So we want the square root of x plus 2. I'm going to match up our graph. Okay. Well, this is sitting on the x-axis at this point, so that's what I'm really looking at. Let's just blow each one of these up. See, that one doesn't match. It should be way over here. That one's not it. Let's look at this one. This one's below. That one's not it. This one's to the right. That's not it. I saved the best for last. There it is. So we've got B. Now, if you don't like doing it with a calculator, we can just make a t-chart, right? You're always free to do that. So you can do an x and a y. You're just going to choose random values that are in your domain. What is your domain? Well, you know, you can't be, x plus 2 has to be bigger or equal to 0, so x has to be bigger or equal to -2. So we can't choose numbers like -4 and -6 and things like that, but we can start with -2, you know, -1, 0, 1, 2, and we can put all of these numbers into the function or the equation, and we can plot points. And then you can do this by hand if you'd like, and then check points that way. Okay? I know we know how to do that, so I would just use a calculator for this, but that's what we do. Let's try another one. Clear this one out of there. We've got, excuse me, the cube root, so we want option 4 of x plus 9, and we're going to evaluate, we're going to just compare graphs again. Yikes. Alright, well, here's my x-axis. Okay, so this one's way below, and this one's way above, so I'm going to choose between B and D. And then look at my y-axis. The bump is to the right of the y-axis on this one, and the bump on mine is way over here. So it's looking more like B, isn't it? The bump is to the left. Yeah. What is this saying here? The graph of this function is shifted off of this function. So what we're going to do is we're going to leave that one in here, and we're going to graph this one alongside it and see what's going on. Okay, so we want the math key, we want option number 4, and we want X. So what we're trying to do is we're trying to see how these have been shifted. Okay, now when I graph these, this one will always come up first and this one will come up second. So you have to kind of look to see, and this one's already in there, so it might not regraph it. So there's my second one. Okay, so we're going to compare this first one to the second one. Which way has it been shifted? Kind of looks to me like it's been shifted to the right, doesn't it? Isn't the bump been shifted to the right 9 units, it looks like? No. How has it been shifted? I'm not a very visual person. Doesn't that look like it's been shifted to the right? Here's my bump here, and then here's my bump there. Has it been shifted downward? No. Has it been shifted upward? No, it's been shifted to the left. Okay, that's sorry. They're asking this one compared to that one. I was going the other way. I was comparing that one to this one. So if I look at this one, then this one's been shifted to the left. That's correct. Okay, so we're comparing the original to our new one, not the other way around. So yes, if I take this one and I look at this one, it's been shifted to the left. So yeah. Okay, let's try some word problems. The total hang time t in seconds is given by t of h is equal to h over 2. Okay, so again, the first thing that I want you to do is I want you to label your sides. Come on. Dang it. T of h is equal to the square root of h over 2. This is an h. Okay, so what is the input? It says h is the maximum height in feet. So h is the height. And what's your output? Well, it says hang time. Have you ever done jump shots on a basketball hoop? And when you jump up, okay, let me draw you a picture. Let me draw you a really, really bad picture. Okay, so we've got the basketball hoop here. There's the net. And as you come up, okay, you're this little guy here with the basketball. Okay, as you come up and jump up to do a jump shot, okay, the higher you jump, the more you're going to be hanging in the air, correct? So this formula here will tell you how long you're in the air. It says if a robot jumps 10 feet off the ground, a robot jumps 10 feet off the ground, determine for how many seconds the robot's in the air. Okay, so we've been given the height, and we want to know the hang time. So we have evaluating this at 10, and we have square root of 10, so we're going to replace an x or an h with a 10. And it says to round to the nearest hundredth. So we will do that. Second function, square root 10. Close your parenthesis. That's why it's really important to close, to get in the habit of closing those. Okay, so we've got 1.58 seconds. Let me see, is this one? That's all. That's all we have there. 1.58 seconds. So obviously the higher you go, the longer you're in the air. The lower you go, the less you're in the air. Same thing here, hang time for golf balls. Okay, this is your height, this is your hang time. what's it, 1 decimal. All right, and that's it. So 10.1 is the basics of radicals, and then we'll keep going with our radical stuff and the further we get into chapter 10. So nice and short, only 30 seconds on this, or 30 minutes on this video. So good luck with your homework.